in this video, we're going to talk about equivalent ratios and what we can tell from those equivalencies. So in the first problem here, we're going to take a look at kind of a basic conversion type table that just helps us move forward for our different numbers that we're given, and they're all going to have the same relationship. And then we're also going to take a look at a similar type relationship down in the second one. We're going to graph that, and then we're going to use those two pieces of information to create an equation. All right, so for this first one, we have Martina is driving her motorhome. It uses 2 gallons of gas for every 18 miles she travels. So we can see they're giving us the relationship here. 2 gallons for every 18 miles. So here's 18 miles that she drove. Here's 2 gallons. So that's our very first ratio in this table. So the first thing we want to do is bring it down to some kind of unit rate so that it's comparable to the rest of them, because it makes it much easier to apply. So instead of 2 over 18, what I want to do is I want to turn one of these into 1. Well, 2 is kind of the easier one to turn into 1 there because I can divide by 2. 2 divided by 2 is 1. 18 divided by 2, because whatever I did to the top, I have to do the bottom, is 9. So now for every 9 miles she drives, she uses 1 gallon of gas. So this is what we want to use. So to apply this to the table, what we would do is if I'm looking at the number of gallons, I'd multiply by 9, and that'll tell me the distance. 2 times 9 is 18. And then if I'm looking at the distance, I'm going to divide by 9, because that'll tell me the number of gallons I used. 18 divided by 9 is 2. So it just depends on, am I given the distance or am I given the number of gallons? So this first one, I'm given the distance, so I'm going to divide by 9. 36 divided by 9 is 4. So if she drives 36 miles, she uses 4 gallons. This third one, I'm given my number of gallons, so I'm going to multiply by 9, because every single one of those gallons she used, she drove 9 miles. So 5 times 9 is 45, so she must have driven 45 miles. Now I'm given the number of miles again, so I'm going to divide, because I want to know how many 9s are in there. Every single one of those 9s uses 1 gallon of gas. So 72 divided by 9 is 8. So she used up 8 gallons of gas, driving 72 miles. And the last one, they gave us 9 gallons of gas has been used. So I'm going to multiply by 9 to get 81 miles. All right. So now we're going to take a look at ordered pairs for a somewhat similar situation. So it's a similar relationship anyway. So Milan is selling raffle tickets. The table shows the cost in dollars of buying different numbers of tickets. So here are the number of tickets. I buy 1 ticket, 2 tickets, 3 tickets, 6 tickets. And here's the cost for those. So if I buy 1 ticket, it costs me $2. If I buy 2 tickets, it costs me $4. So it just gives me this kind of relationship here. And it even describes, it tells us a little bit more using X for the number of tickets, so I can see that here, and Y for the cost. Okay, so we're going to do the following 2 things. We're going to plot the ordered pairs described by the table, and then we're going to write an equation relating X to Y. And we'll answer these questions in just a moment, because these are kind of extra questions to help us build the equation. So let's go ahead and graph these. So remember, tickets, that's X. So I'm going to write tickets down here. Just keep this in mind. This is the number of tickets. And then cost, that's Y. So this is the cost. So the first one, if I buy 1 ticket, it costs me $2. Second one, if I buy 2 tickets, it costs me $4. If I buy 3 tickets, it costs me $6. And if I buy 6 tickets, it costs me $12. So here we have a linear relationship. There's the line. So I can see as I'm buying more tickets, my cost is going up. So they're both going up together, which is why this is a positive slope. They're both going up. So for this one, we can see this visual relationship. So now we have to ask a question. We need a starting point to start writing our equation. I need somewhere to start from. So what that means is at the very beginning, how many tickets did Milan sell? So, and a lot of students will go back and go, oh, 1 ticket, because that's the beginning of the chart. I'm not talking about the beginning of the chart. I'm talking about the very beginning of the raffle, when this person walked in the room and said, raffle starts. How many tickets have they sold? Well, 0, right? It just started. They haven't sold anything yet. So the true starting point is actually here at the 0 mark. And how much would that cost? Well, it should cost 0. They haven't sold anything, so there's no cost there for the number of tickets. So the starting point is 0, 0. I haven't sold any tickets. It hasn't cost any money. And then we also need to know how much does it cost per ticket, because this is going to be our change, or what's called our slope. So this is the rate at which it's increasing per ticket. So on the table, I actually see one ticket costs $2. So we just want to make sure, does this relationship hold true for all of them? So 2 tickets cost $4. Well, if I do 4 divided by 2, I get 2. 3 tickets divided by 6, because 3 tickets cost 6, so let's go 6 divided by 3. Well, I get $2 again. That's $2 per ticket. And then 6 tickets cost $12, so if I divide by 6, it costs $2 again. So 2 is our magic number there. That's how much each ticket costs, is $2. So now to write our equation, we're going to have our total, or our cost, equals our starting point, plus our change. Change. And change is change per something. Okay, so I'm just going to write change per. So with this one, starting point is also referred to as the Y-intercept, which is the point where it crosses the Y-axis here. So it crosses the Y-axis at 0, and we also noted that it's 0 for our starting point. Plus, I'm doing that kind of bold so you can see that, the slope. And the slope is also always multiplied by a variable, because it's changing each time. And in this case, we can see that. If I buy 1 ticket, it's $2. If I buy 2 tickets, it's $4. If I buy 3 tickets, it's $6. So what's changing, what I'm changing here, is the number of tickets that are being sold or bought. Okay? So slope times, it's going to be a quantity, which we'll just go ahead and write x here just to make that a little easier. And the total, they're asking me to do y in this one for the total cost. So y is going to equal the y-intercept, which is our starting point, plus our slope, which is our change, what does it cost each time, times whatever it is we're either buying, selling, whatever the item is. In this case, we're selling tickets, but it could be a different scenario when you go and do this on Alex. So y equals, our starting point is 0, plus our change, our slope, is going to be $2 per ticket. So 2 times x. So when I actually write this as the equation, I do not need to write 0 plus, because anything plus 0 is itself. That's an identity property of addition. So I can just write y equals 2x. All right, so this is equivalent ratios and writing an equation using equivalent ratios. So go ahead and go on Alex and give that a try.